Welcome to this talk, 10 things about testing that you might have heard are wrong, or something like this on agenda. I shortened it a bit because it's really hard to remember title, but it's the same thing. We talk about 10 things that you might have heard about testing, that you might have believed, that I might have believed, that sometimes that I want to question a bit. Who am I? I'm from Berlin. So I realized that I finished university over 20 years ago. Then for a long time worked more like in embedded field, C++ things, embedded printers and stuff. Then these feature phones came, and then some Java knowledge was used there. At some point I ended up Blackberries. Someone said, hey, then you know Java, right? These Blackberries can do Java now. And then Blackberry was dying. I had to jump on another train, so Android came up. And this is where I'm still until now. Working at SoundCloud over 5 years now. Running the Android team right now. There's Android for my team. I hope you will not disagree with all the things I'm saying here. Let's see. Yeah, so I work for SoundCloud. But I've heard, I think we are one of the 2 DSPs that actually makes money. World large audio catalog. If you are an artist, hopefully you're using SoundCloud to upload your music. Definitely, I think if you're into electronic music or hip hop, you will do. But let's talk about this talk. I like to start off with this one because this was the very first talk I talked about publicly as a developer. This was the BlackBerry Developer Conference 2008 in Santa Clara, California. And it was about testing, which is a bit like, oh no, another testing talk from Danny here. So it kind of kept haunting me. And the idea to this talk came, can't remember when, but what I realized is that especially when I look back at talks like this, when I would look at the slides, I probably would disagree with a lot of things that I said back then. Because there were some things that I was they would fight for, that I believed is true. And I would argue with my colleagues, no, this is the way we have to do it. And then I realized maybe there's a better way, or maybe I was too dogmatic there. And then another colleague comes, and I realize he has the same opinion I had a couple of years ago. There's a new Danny that now have to argue. These things accumulated. So I thought, let's try to gather some of these learnings and put it on. And you can come afterwards to me and tell me you completely disagree. If you so come and tell me that. If you agree partially, let's have discussions afterwards. So there's not so much code in this. The way I wanted to give this talk is, although these are my learnings that I had over the years, I try to underline. Let me not touch anything here. Try to underline with a lot of quotes from people that you know, from people that you might not know. So the heroes in our industry, trying to, most of them actually found the things much earlier than I did. So let's see. So what is a myth? Because I renamed it to 10 myths about testing. A myth is a widely held but false belief or idea. So things we believed were true, but actually they're not. But a lot of people believe them. So let me be clear. One of the reasons also I want to give this talk, I feel like there's a wave in the industry that votes against testing. That think, maybe because we went too far, maybe because we went too dogmatic, saying, this is not worth it. And I heard it from colleagues. Let's drop all the testing. It's the worst thing that happened to our industry. So let me be clear. I agree with Michael Feathers. Code without test is a bad code. It doesn't matter how well written it is. It doesn't matter how pretty, object-oriented, or well encapsulated it is. Code without test is bad code. And I believe in it. Although I question a lot of other things, in this one I still believe. So let's talk about the myths. Let's start with a very simple one that definitely I see myself as a very young developer believing that any change should lead to a failing test. I remember I was always very proud when I wrote the first unit test in a project and I changed something and the test went red and I said, yes, that's how it's supposed to be, right? Let's talk about this. 90% of the time, a unit test fails not because of a bug, but because of changes in implementation details, new dependencies, refactoring, bugs in the test itself, or incorrect mock setup. Often they don't prevent us from introducing bugs, but from introducing changes. So let's have a quick recap thinking about this. Martin Fowler said, refactoring means changing the internal structure of your code without changing the external behavior. So why should your test fail when we do the refactoring part? Or I think this is Uncle Bob, but I wasn't sure. What your software does is stable. How it does this is unstable. And that's something we have to keep in mind for testing. And I actually have a nice example here that is a real example I had in the company I worked before SoundCloud. I had a chance, I worked on a greenfield project there, could do like TDD approach fully, it was a very nice experience. And then a new colleague came in to help me building this app. And I remember he wanted to introduce Redux in the architecture of the app. And I said, let's focus on shipping and then afterwards talk about it. And then one Monday I came in and he said, by the way, Danny, I did all the Redux integration. Don't worry, I did on the weekend. Not really what I wanted to do, but let's talk about this. So before I had a test like this, there was a view model test that covered actually the view model, the repository, and the API. So very different than the usual approach that you would have that probably would like this, right? View model test, repository test, and API test. The reason was that, as I said, I was writing this TDD. So I started with the view model, and then the other things appeared step by step. But why would I change the test? Because the behavior of the view model didn't change. So then my colleague came in Monday morning, the pull request was merged, and we had Redux. So basically, there were new things in between, store, reducers, side effects. The interesting part is that the test was still working. We had to update some dependencies, but the test was still fine. It was green. Because what the software does didn't change. Just how it did, it changed. If you would have had tests like this, we could have thrown them away or have to change them all. And imagine we would have tests like this. The store test, the reducer test, these are all completely useless. But this is what we're doing. This is what we're doing every day. Take a class, we write a test for all the functions. What we're actually doing is, you all know this meme, is writing these. So maybe we were on the wrong path here. And I can see of some of you will probably say, Danny, but that's not a unit test. So let's talk about this. Martin Fowler again. If you ask 3 different people what a unit means in the context of unit test, you probably receive 4 different slightly nuanced answers. As I said, all these things I also discovered about time. So sometimes I would like blog posts about it. A couple of years ago, I asked myself, what is a unit? But there's also other people that talked about this before. So if you read TDD by example, the book from Kent Beck, it becomes apparent that a unit is a module within an application. And actually, there's a couple of people that try to figure out, when did things change? When did we start thinking of the unit as a class, as a function of a class? And it's not 100% sure who started this, but when you go back in time, it was always a module. Unit meant module in the older days of development. So when you think about unit, or we should think about units more as an element of structure. And not as an element of structure, it's an element of behavior. Because what we just talked about, right? Testing the behavior, not the structure. So the full definition of a unit test should be, unit tests are fast executable specifications of a required behavior. They're not about structure. So when I look at a test like this, and this is something that I think is a Warehouse app. So I had created a service, with a hard-coded JSON file. I created a view model, which is what I wanted to test here, similar to the example I showed you. It's a real auth operation class, and some in-memory settings, not a mock. Some API client that uses this JSON. This is definitely not a classic unit test. It had multiple layers here. But believe me, these tests are much more stable than the one you might have used to. So let's sink this in. We'll come back to this idea of testing behavior and not structure. But let's talk about another one that we've all heard, that we have to write testable code. For years, I remember when I started Android, no one cared about testing. And then we tried to tell people, right, please write tests, write testable code, because we needed all these mocking libraries, and then the libraries to how do we mock static classes and private methods, all this stuff, because we didn't write testable code. But let's look about this sentence a bit more. If you design first and foremost for testability, you get what you pay for, testable code. More often than not, this design will be completely disconnected from the project's business domain and requirements. It will resemble an enormous object graph full of accidental complexities, but it will be testable. Testable by tests that are drowning in mocks and will fail altogether after changing a single bit of implementation. That's what I call test-induced damage. And it's really depicted in DHH TDD is that. So here someone referenced a famous blog post a couple of years ago. DHH, Daniel Heinemann, I think, is the guy who wrote Ruby on Rails. He's very verbal with opinions. Often, many of us disagree. But sometimes often there's actually some truth in that. So, and he talked about test-induced damage. And this is one of the things where I said there is a wave in our industry. He said that testing can actually do more harm than good. And he was blaming TDD. And then there's some response about this. Actually, not TDD. There's other things that are going wrong. But you're right. By writing testable code, we are harming our design. And we all have this from our code. It just didn't have for it long. This is a constructor with tons of completely unrelated things that we all need. And we call this testable code. We think this is good code design, right? A couple of years ago, I wrote this blog post, Forget Art of Construction, because I was super annoyed seeing all these constructors. And I actually had an example of this code in there, which was smaller. Now I open it again, it had even more dependencies. So we all do this. Because it's very easy. We just add the mocks there and then this testable code, right? So let's talk about mocking for a moment. Mocks are very helpful. That's what we use them every day. I'm pretty sure everyone in the room here is using mocks. I like this one. The real reason that so many of us are using dependency injection is to facilitate unit testing using mock objects. We all believe in DI, right? That's a different topic, and mostly we use it for that. Uncle Bob, the need to mock every class interaction forces an explosion of polymorphic interfaces. Lots of extra interface classes. This is over-abstraction and the dreaded design damage. Because of tests, we need an interface. Everything has an interface. Everything we have to mock. This is where it starts. This was Uncle Bob's answer to the design damage one. He gives some tips also. When you mock too much, we create very slow, because especially mocking frameworks like Mockito slow you down in runtime. You have fragile and very complicated tests. And you damage, as I said, design of your application. Or to say it for someone else, if you're mocking, are you even testing? We think this is valid code. Really? Let's think about this. So, reasons to mock by Ian Cooper. We should mock to allow our tests to run faster and independently, but not to isolate things on a test. This idea of isolating one clutch from each other and then mock the other one, this brings us in the wrong direction. So, Uncle Bob again, mock across architectural significant boundaries. We can think about also modules here again, right? Not within those boundaries. Please write your own mocks. Get rid of your mocking frameworks, right? Stubs and co. We use mocking tools in general. So if we have like an off-client interface with just one method, just create a stub. Like you don't need a mock for this thing. Or something like this, something that I also do just from the code. We have shared preference with an editor stub. This is a real thing, it's just a hash map underneath. Why should I mock this? Mocking often brings in a super weird situations where, oh, your mock is empty, but then you're checking size equals 0. This is the same thing, but your mocking framework will not know about this. So try to use some stubs at least. And please, 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 never mock data classes. If you do this, I don't know, I think, if I see his colleague doing this, maybe start with a one-on-one in programming. Like, please, please, please do not do this. There should be no reason to do that. So let's talk about another one and park this topic here a bit. Test coverage. And I definitely see myself in the next code. So junior devs, when you're asked about the code coverage, will say something, it's just 35%. And then there's a mid-level, yeah, I'm almost there, 95%. And then you ask some seniors, man, I don't even know where to find this number. And I see myself in all these levels. So let's talk about host coverage. Host coverage is a useful tool for finding the untested parts of your code base. Nothing more, nothing less. This is all it can give you. Everything else is bullshit. So monitoring or enforcing code coverage may do more harm than good, because it incentivizes writing junk tests. And even worse, it creates a false picture of your actual test coverage. We all know they can write a very long test with a lot of test coverage, not having a single assert there. Test coverage is great. I've seen all of this. Everything is green, and managers, they had a real traffic light in their office in one company I worked for. And everything is green, and look at all dashboards. And then talk to the developers. Yeah, we disabled this test a long time ago. But everything is green, and the code coverage also runs, right? But it didn't make they checked anything. And I remember like me in one of his earlier stages, I was enforcing this every day, looked at the sonar graphs. Oh yeah, I'm getting there where the backend is. And then we had rules and test coverage can never go down. And then, okay, let me tweak this one thing because I need to check this in now. It's like, what are we doing? We are becoming a bit too dogmatic. So measuring your test coverage, this is my boss actually. Measuring your test coverage is like judging a song by how many notes it has. You can do that, but you're probably missing the whole point. So, but I want to mention another thing, because also like a lot of the things brought me back to something earlier in my career. So many, many years ago, I found this thing, the way of test reviews. It's like ancient wisdom from a startup back in the day, in the ancient days. It's a PDF, you can still find it. And there's one story about here that is related. The pupil went to the master programmer and said, all my tests pass all the time. Don't I deserve a raise? The master slapped the pupil and replied, if all your tests pass all the time, you need to write better tests. So maybe there's something wrong with the test in the first place. And with a red cheek, the pupil went to HR to complain, but that's another story. So I can recommend the way of test reviews, but this is the whole idea, right? The tests are green, but do they actually make sense? So I try to figure out for this talk, what's the code coverage in the SoundCloud code base. I got this weird error in Visual Studio. I had no idea what it does, but it just doesn't work. The test coverage didn't work. So I gave up looking for it. So I don't know where to find this number. We have a lot of tests. These tests saved my ass many, many times, but I have no idea what the coverage is. Which brought us to another thing that is very, very related to the 5 years I've been in SoundCloud. The belief that flaky tests can be fixed. And if you've been to the really good talk from Jose earlier before lunch, they talked about flaky tests and what you can do. So let's talk about flaky tests. A study in 2022 showed that over half of developers experience flaky tests every month. I would have thought it's even more. And according to another survey, 41% of tests at Google that passed and failed once or more were flaky. The same as 26 for Microsoft. I think we all can relate. I'm pretty sure we all seen flaky tests all the time. So this is another post of someone from some Google iOS code, I think, saying, yeah, ignore this here, this fails every once in a while. So let's talk about this. As the number of tests grows statistically, so will the number of flakes. If each test has a 0.1% of failing when it should not, and you run 10,000 tests per day, you will investigate 10 flakes per day. That's the same what Jose said. Just statistically, on CI, we run all these tests. You have constant them, even if the chances are really low of them being flaky. And fighting flakiness can sometimes feel like fighting entropy. You know it's a losing battle, and it's a battle you must engage in again and again and again. And then you feel like this. Definitely, I've been there, and at SoundCloud, we followed like all the best practices. Like we were set at talks at these conferences, and then this is how they do it. We have a build sheriff rule. If something is red, immediately build sheriff jumps on it, evaluates it, reruns it if it's still red, writes a ticket if you can't fix it once a week. We look at flaky test graph. We write tickets. We try to fix them. Do all the things. But very often it felt like this. That's what you did the last years, for sure. So if the test flakiness continues to grow, you will experience something much worse than the loss in productivity that we had. It's a loss of confidence in the test. I mean, we literally think, and it's also was what Jose showed this morning, one of the things you will do at some point of flakiness is rerun. So on CI, we have all these Gradle plugins, and so, if it fails, just run again. If it's done green, it's fine. Is it? Or maybe something hidden, right? So we might not trust our test anymore. If it's okay that the test and rerun solves it, maybe we're really doing something wrong here. So after wasting many times at SoundCloud to trying to fix our flaky tests, we recently dropped all our UI tests. The iOS team did it first. We thought it's not completely true, but we made a very hard decision to drop them because we spent so much time trying to fix them, moving them to we had old tests from Robotium to Espresso, idling resource monitor, all these processes. We did all these things. But to certain things, tests will stay flaky. And when is the moment that you give up? I'll come back to how we're doing it now a bit later. But let's first talk about that we have to test all the things. We have to automate as much as possible. Better create a whole team that does nothing else than just automating things the whole day, right? Let's talk about it. This is DHA, the guy that talked about test-induced design damage. The problem with calling out over-testing is that it's hard to boil down to a catchy phrase. There's nothing succinct like test force, red, green, or other sexy terms. But there is such thing as over-testing. So what's the cost to prevent a bug? How many thousand lines of code is it worth writing to catch a one-time accident? This is how this iOS team at SoundCloud actually started. They had this one test that had to keep updating. It always failed, and they looked at it, and I always had to change it. And at some point, their boss said, can we check when the last time we found a bug with this? And I think it was like 3 years ago. So the amount of time spent there was completely useless. So in software testing, there's a so-called Pareto principle that you can interpret as 80% of the bugs can be found in 20% of the modules. So maybe we should focus on these 20% instead of trying to automate the rest. Because there's this 80-20 rule everywhere, right? There is like 80% you can get a 20% effort. And then afterwards it gets harder. And the same with automation. So, which brings us to exactly this. The duplicating, so testing things multiple times on multiple layers of the pyramid is something we should aim for. So while your gut feeling, Michael Fowler, might say, there's no such thing as too many tests. Let me assure you there is. Every single test in your test suite is additional baggage. It does not come for free. Writing and maintaining tests takes time. Reading and understanding other people's tests takes time. And of course, running tests take time. As a production code, you should strive for simplicity and avoid duplication. There's like, this is this weird thing of us developers, like we learn all these rules and can discuss if clean code is a good or bad book, but we follow like certain rules and keep our code clean. Are we doing the same with our tests? Often not, and especially when it comes to avoid duplications. Martin Fowler gives some tips. I delete higher level tests that are already covered on a lower level when you think about the pyramid. There's no reason to waste more time on a test that keys to provide value. It is okay to write tests. These tests that test a feature flag that is turned on production for years. Time to delete it? That's fine. So last time I wrote an espresso test at SoundCloud many years ago, but I write like daily tests on if I'm manager now, if I write code, then I write tests. But espresso tests a long time ago, so this was even before we dropped them. So let's maybe focus on the important things. For me, this was always the unit test. Does not say, I mean, the unit test is a wide range. What does it mean? It's a unit, we talked about it. And there's also like a composer and so, but we talk about this in a bit. But there's one thing, important thing, we have to automate all the things. So test all the things, but also automate everything. Again, best you create a team, a core team or something that does nothing but automating your things, put them on CI. At another layer, we need all these safety net layers, right? So there's a actually very simple rule I found that tells you what you should automate. You should automate 100% of the tests that should be automated. So how to see this? We nice blog post where that started like this. So usually you have something like this, and I think Jose showed something similar. You're investing in a test, and you might invest in writing the whole thing, automating this test case. But at a certain point, you need this reach this break-even point. For this test I mentioned that the iOS team has, they never reach that point. They kept investing. The hard thing is to figure out what is this time point. But if you never get closer to this, if it's looked like this, maybe this is not a task you should automate. And there is the guy in this conference, he hides pin everywhere, Ben Cadell. And you find this talk online from him, which I think is one of the best talk I've seen, not only because he's a good actor. He shows tons of ADB commands that you can use. Why do I mention this? Because, as I said, the iOS team started first dropping off all their tests. That doesn't mean they don't test. But they don't run these automated CI tests. They have tons of script that someone as part of regression runs. But there is a person in front of a computer, in front of the emulator, who runs this test, and he looks at it. If there's something weird, he just restarts it. Not 2 hours later, when he gets the report of 3 times rerun, realized, Oh, I think there was something of the emulator. Let's start again. So less automation actually makes them faster here. And if you want to do the same on Android, there's a lot of great stuff in there. Basically, Ben grabs the screen with one command, use like all the stuff that you at university, grab and set and all these command line tools, pass into something, clicks on a button, it's super cool stuff. And it's just command line scripts. It's not fully automated. It's not what we learned, right? It's not a right espresso test when I want CI. But maybe there's some of the things, semi-automatic is fine. So there's nearly all the talks here have to mention AI. And of course, there's a new wave of, let's talk about AI in test. You know, writing tests takes time. Let's generate tests. AI will solve all our problems. Thank you. So let's say, what value can AI, doesn't matter if it's Gemini or one of the other ones, can give us? So let's start with the first idea. Can we generate the tests from the code? Because writing tests no one enjoys. Let's just generate them by the code and we can finally get rid of this problem, right? And it's very funny, although this whole Gen AI stuff is very up to date, the idea itself is not new. When I was younger, the guy that wrote this TestEvos PDF, he had this amazing tool in 2017, the JUnit Factory. It was a website where you upload a class and it would and you download the test class for it. And as a young developer, I was amazing, all these use cases, and it was super cool, I thought. The product, I think it died. Maybe there was a reason. So let's talk about this idea. The test that you will write now, so when you write after you write your code, will tend to establish and support the existing reality you have created. But what if that string transformation is wrong, and it wasn't the programmer's intent? We will never know. Taking a code and generating tests, this is just documentation of what you've written. You're not testing anything, it's a specification, maybe that's fine, not a specification, it's documentation. It's part of what a test is, but not everything. And there's a thing here. Tests usually, and test and code, according to Uncle Bob, they move into different directions. One gets more generic, while the other one gets more specific. If you don't treat tests as part of your system, if you don't think about decoupling, separation, isolation, you will damage your design. If you just generate code for one class and generate code for another one, there is no deduplication. They're one-to-one mappings. They don't evolve. These are junk tests, and probably you have to regenerate them next time you change something. So let's take another idea. Maybe this one was bad. We take some bullet points and we generate the test out of it. And it's kind of what we've seen today in the talk and yesterday when you were at the Android show. There's now an AI tool where you write human-readable code and it does the testing. So some people thought about this before. So the whole point of TDD was to use tests as executable specifications, written in a precise language instead of the old design documents, which in natural language. The whole idea is we are writing a test in the same language we're writing our code, and not in a Word doc or whatever. So applying this kind of AI approach to software development will result in code that is impossible to maintain and requires rewriting from scratch. So this is a bit different than at yesterday. This is we are generating from bullet points the tests. But the approach that we've seen yesterday with Journey reminds me of this one. This is THH. Don't use Cucumber unless you live in the magic kingdom of non-programmers writing tests. And please send me a bottle of fairy dust if you're there. Cucumber is a framework where you write in natural language your tests. And there's a version for Android that basically underneath uses Espresso. So just a layer of things. So this doesn't work. And companies, for the last time we have this talk, someone came to me, yeah, we use Cucumber. And I felt really sad for him. And you could tell him his face that it doesn't work. It's like using Appium, but on a even further level. So this approach was a one-to-one mapping of human language to code. Now we have something which is non-deterministic. We use like an LLM. We don't know when we run it what will happen, what it will do. Is this really what will solve our problems? Another thing so this morning, Jose showed an example that makes a lot of sense to me. The Google Maps team was using this approach for testing. I can totally see how hard it is to verify something on Google Maps. But the examples of pressing a button, I don't know, when I wrote the espresso test, for me, the problem was never writing a test. There were a few lines of code. Most of the things you have abstracted out. So clicking a few buttons was never my problem. Keeping them stable was my problem. Keeping them running was the problem. Not sure if an LLM will help you here. And most of the time, it's not the non-programs who should write this test. So there's another thing. What is a valuable test? If you can swap up the whole implementation underneath and keep the test, that is a valuable test. There's an interesting discussion that you can find online with a couple of Uncle Bob and co, where they all asked, you have two disks, your test code and your implementation. You will lose one. Which one will you give up? And they discussed, and they all agreed they want to lose the implementation. Because with a good test suite, you can rewrite the implementation. You will never rewrite the tests. Impossible. You can generate them, but not sure. So maybe, let's not go this path. AI is a TDD buddy. You know, when you pair, one writes the test and the other writes the implementation. Maybe we can finally use AI for that. Folks tried this. They definitely found you must specify your requirements very, very precisely. Otherwise, the LM will make assumptions. Be aware, never use code without fully understanding it. I mean, the whole idea of when you use like autocomplete, you will see this all the time nowadays. Back in the days, we copied from Stack Overflow. Now we have a tool that is trained on Stack Overflow that will generate the code. So please, please. They actually said that sometimes the code looked like it's doing the right thing, but it didn't. So really try to understand the code that someone's generating here for you. There's a droidcon Berlin talk from Matthias Geisler, who's not here. Please check it out. He was mentioning, because it was all about using TDD with AI, and he mentioned this white paper where they basically found that it definitely increased the copy and pasting, and it had an increase in code churn. So reverted lines afterwards increased. Because they realized, oh, maybe this wasn't right. It just looked right. So they actually using this was the overall decline in code quality. And what I've seen so far, all the studies is showing this. So using these tools will lead to a decrease in code quality. Maybe we're getting better. Who knows? But be careful. So what can we use it for? It can be useful. It can help us find unspecified parts of your tests. Maybe when you were not precise enough, there was something not specified. Similar to code coverage, it helps us the untested part of the code. You can use generate test inputs, edge cases. This was a nice thing with this JUnit factory. Yeah, this edge case of like integer max. You have to write it. Someone can write it if you need it. I use a lot to generate test fixtures. I need like inputs. This is something I use like Gemini and Android Studio, for example, for. But it's not like it takes do the testing for you. So that's also one thing that I love that Jose brought up this morning. Let's talk about the testing pyramid. Because everything that we do is built kind of on this model. This is the original post. So the unit tests, they're very fast. We have a lot of them. And then we have other layers up with different names. And the end-UI test, we have a few, they're very slow. Also, the further up, the more flaky. Let's more precise. A lot of companies don't have a pyramid. They have what's called the ice cream cone. Hardly any unit tests, a lot of UI tests. Then you're doing something wrong. So, but if you're following this, let's talk about this. So Fowler himself, unfortunately, the concept of the testing pyramid falls a little short if you take a closer look. From a modern point of view, it seems a bit oversimplistic and can even be misleading. Other folks say, truth to be told, this kind of outlives its usefulness. I think it gave us a nice direction, but things also changed. So this one I just copied from Jose's talk from this morning. Sorry for the bad quality. There's one, this doesn't even look like a pyramid. So they renamed the pyramid in different categories and also said for some applications, this might be totally fine. Found it very interesting. So read, if you haven't been there, watch the summary. But what changed? So not all unit tests are local anymore. Not all to-end tests run a device. Think about robolectic and things like this. There's a lot of things here. What are robolectic tests, right? We used to use them as kind of a unit test because we put everything in activity. where does be the unit test, right? What is it? Now we're using it for compose. So over the years, me and Robo Electric, very different views. Sometimes recommend, sometimes says please don't use it. So mocks itself is slow when we use Mockito. And then the last one is the most important one. So we have to look at the execution speed of the test, the build speed, and the network. Let me give you an example. Modularization. So we have a lot of modules. At some point, Google said as many as possible, right? So we all have hundreds of modules, probably. For incremental builds, it's good. On CI, we build everything. Probably the build is slower than it was with one module. Then we trying to speed up our tests, and then we followed one idea that also I think came from Google. Has separate applications, so don't have all the espresso tests in one bucket, but have specific test applications that test that specific the part. The interesting part that we saw is we had to generate now multiple APKs, so that build time went up, and then we had to transfer these APKs to Firebase Testing Clouds over the network. That went up, and overall this was slower than running them all in one bucket. So very interesting. So it wasn't as simple as we thought it would be. So there's just more aspects here nowadays. And I liked, this is actually from the Android Fundamentals testing guide. They completely think a different direction. So maybe instead of these categories, have something like this functional test, their performance test, there's accessibility test, and compatibility test. And you can use different tools on different these layers. But they don't really, I like this Jose this out this morning, actually the pyramid is not a pyramid, it's a triangle. Maybe there are different angles that we don't see. So just question the pyramid a little bit and maybe rethink your testing strategy instead of just adding more layers in this pyramid. So let's talk about the move that we talked about today. Any change should lead to a failing test. That's not a unit any. Please write testable code. Mocks are helpful. Test coverage is helpful. We can fix those flaky tests. We have to test all the things, and duplication is okay on different layers. And we have to automate all the test cases. Generate our tests anyway for AI and for a testing pyramid. As you can see, there are 11, not 10. Some are a bit related, so I said I can let you through one more. So in the end, take one thing out, be a bit more pragmatic. Try to use less mocks. Don't repeat yourself. Please test behavior, not structure. But please write tests. So let's finish with some quotes. Google engineering team has this Beyonce rule I learned. State that if you like it, you should put a test on it. And in a perfect TDD world, untested code doesn't exist in the first place. I like that. There's one talk that I recommend you to watch. It's this one. TDD, where did it all go wrong? Where Ian Cooper looks into this topic. And this is less about TDD, but you realize, you know, like the usage of mocks, the use of these use constructors. It's the first time I heard about this. And he warned about this, that the whole Java enterprise industry went in a completely different, wrong way. And there he looks at, why do people hate TDD and testing? And it's actually because the way they're writing it, which especially it's about mocking. So let's end with the testivus, do good things to testing and good things will happen to you. And with this, I will close this and thank you very much. I would say if you have questions, let's have a discussion afterwards so that the next speaker can already set up here. I'll be around. I'm happy to have a discussion about this. Thanks.